In this video, we're going to talk about how to work with rational expressions. So let's talk about what the word rational means. Rational is just another way of saying fraction or fractional expressions. So we're going to be looking at our favorite things. We're going to be looking at a ton of fractions, and all of these fractions are going to be filled with lots of variables for us to work with. So if you will notice, here's an example of the type of problems that we will be looking at. We've got just some plain reducing, so we're writing each rational expression in lowest terms. We've got some indicated operations. We've got multiplication, division, and then lovely addition and subtraction. Now, one of the things I want to point out here that you may not realize, typically multiplication and division are easier operations to work with than addition and subtraction are, and we are going to see that with these problems. Now, again, I do have some notes posted for you on our Moodle page. So here's everything you need to know about rational expressions. It tells you how to simplify, how to multiply, divide, add, subtract, and then how to simplify complex rational expressions. I don't think we see any of those in our homework, so don't worry too much about that last little bit there, but it's there if you need it. So instead of me going through all of these, I'm just going to jump right into the problems so that we can look at them. So let me close this. And I want to bring up our whiteboard. Let's clear this out. I'm terrible about clearing my screen. Okay, so let's look at number 2. And they give us this cute little problem of 25 p cubed p over 10p squared. So when you're talking about rational expressions and you're talking about reducing, you are talking about factors. You're talking about, if you've got binomials or trinomials, you're talking about factoring. These two things we have are monomials. So I have a monomial on the top and a monomial on the bottom. Monomials are much easier to work with. You don't have to worry about having factors like binomials and all that. So the way that monomials work is you are allowed to cancel just individual pieces. Now, this is not going to be the case with binomials or trinomials or 4 terms. When you have binomials or trinomials, meaning you have plus or minus signs in any of it, you do have to have the same exact thing on top and bottom to be able to cancel. So here, I'm going to cancel this or reduce this just like I do with any particular fraction. I'm going to look at it and say, okay, yeah, 25 over 10, 25 and 10 is both divisible by 5. So I'm going to divide a 5 out. So that's going to leave me with a 5 and a 2. And then the way that the exponents work is you look at them and you say, okay, I've got 3 p's on top. I've got 2 p's on bottom. If I think about what's going to cancel out, I see 2 of the p's canceling out on top and bottom, which is going to leave me with 1 p on top. Another way that you can do this is your rules of exponents. You can say, okay, p cubed divided by p squared. If I'm dividing, the rule says that I'm going to subtract my exponents, so I get a p to the 1 on top. If you want more information about that, check out my video on how to work with your exponents. Okay, so that's it. 5p over 2, done. Again, monomial is much simpler to work with. Let me go ahead. I'm going to put number 8 up. I'm going to show you the difference. So with number 8, if you will notice the big difference between number 2 and number 8, number 2 had no plus or minus signs. Number 8's got all kinds of plus or minus signs. So when you have a problem like this, your first step is to factor. I'm going to factor the top. I'm going to factor the bottom. So if I factor the top, I'm looking for factors of -6 that are going to add to be -1. I go through that whole entire process, and if I do that, and if you have problems with this or questions about this, check out the video on factoring. I'm going to skip that step. If I factor this out, I'm going to end up with r minus 3 times r plus 2 over r plus 4 times r minus 3. So I've factored the top, I've factored the bottom. This is what I'm left with. So here's the way it works. To reduce this, you have to have the same exact thing on top and bottom. So the only thing that I see that is the exact same is an r minus 3. So I'm going to cancel out r minus 3. And that's going to leave me with r plus 2 times r plus 4. Or excuse me, divided by r plus 4. That's it. I cannot cancel out these r's. You are not allowed to cancel out pieces of addition or subtraction. That's bad. You don't want to do that. Guys, that's equivalent to if you had like this statement, like 100 over 10, something like that. That would be equivalent if you, like if I canceled these two r's out from the r plus 2, r plus 4, that'd be equivalent to me marking out the ones here. That's wrong. That feels bad. That looks bad. We do not want to do that. So I am left with r plus 2 over r plus 4. That is my final answer. All right, cool. So let's do another one. I want to look at number 16. So the first two problems, number 2 and number 8, it was just reducing. I'm reducing it to its lowest term. So there's no operations going on, just reducing. Okay. So number 16, we're going to change gears. I have a minus 3 over 16 divided by a minus 3 over 32. So division and multiplication are very closely related. Here's the thing about division with rational expressions. We are not going to do division. You never, ever, ever do division with these problems. Instead, you're going to change division to be multiplication by the reciprocal. Now that's a mouthful. So another way of thinking about it is you're going to keep, change, flip. You're going to keep your first fraction the same. So a minus 3 over 16. You are going to change division to be multiplication. And you are going to flip the second fraction. Or, if you want to sound smart with all your friends, you're multiplying by the reciprocal. That's what we're doing. So once you have accomplished this step, your next thing to do is if you've got a lot of binomials and trinomials going on, you want to try to factor. Now, this problem is really nice. It's really straightforward. I don't have to do any factoring. A minus 3 is completely factored. With 16 and 32, they're both monomials, meaning they don't have addition or subtraction attached to them. So those are going to work just like fractions. So what I want to remind you with fractions is you are allowed to reduce across the multiplication sign diagonally or straight up and down. Let me do a similar problem right quick. Let's do, I don't know, what if I had 15 thirds times 9 fifths. So what if I had something that looked like that? So a problem, back from middle school. How would we reduce this? So there's two ways to do it. You can multiply straight across and then reduce. That's the hard way to do it. And guys, we learn math so we don't have to do it the hard way. So the easy way is you reduce diagonally or straight up and down across that multiplication sign. So when I mean diagonally is I can say, oh, look, there's a 15. There's a 5. Oh, yeah, 15 and 5 are both divisible by 5. So let's divide them both by 5. Give me blue. Okay. So 15 divided by 5 is 3. 5 divided by 5 is 1. Cool. And then I see a 3 over 3, which I can reduce that if I wanted to, or I can do 3 over 9. It's your call. It doesn't make any difference because it's going to work out either way. Math is awesome like that. I'm going to get crazy. I'm going to reduce the 3 over 3 to be a 1 and a 1. That's basically everything that's going to reduce. So here I've got 1 times 9, which is 9. 1 times 1 is 1. So we end up with 9. So just like you did that problem in middle school, I am now going to do the same thing with this problem that we have over here. So the first thing I want to deal with is let's look at the 16 and the 32. So that's diagonal, 16 and 32, both divisible by 16. So I'm going to divide out the 16. So 16 divided by 16 is 1. 32 divided by 16 is 2. All right. Now, we've got an a minus 3, a minus 3. If you will recall, you are allowed to cancel binomials as long as the binomials match. So because I have an a minus 3 and an a minus 3 diagonally, I can cancel those twos out. That becomes a 1 and a 1. Our final answer here is going to be 2 over 1 or just 2. Okay, so if you were given a multiplication problem, let's say that this step up here was not here. So let's say we took that out for just a second. If I was given this problem, you do it the same way we just did it. So multiplication, you factor everything out if it can be factored, and then you cancel what you can out. Division's an extra step. You have to change your division to be multiplication. Guys, you do not change multiplication. If you start out with a multiplication problem, you leave it alone. You're going to see me do the division problems because it's adding on that extra step, and I want to make sure that you're comfortable with the extra step. Multiplication problems work the same way. It's just you don't change the multiplication, just factor and cancel. All right, let's do another division problem. And I'm going to make it very entertaining. So let's do number 22. So number 22, they give me m squared plus 3m plus 2 over m squared plus 5m plus 4 divided by m squared plus 5m plus 6 over m squared plus 10m plus 24. Okay. The first thing that I notice is that this is a division problem. So I'm going to fix my division to be multiplication. If this started out as a multiplication problem, you wouldn't have to do this. You would just start factoring. But because it's division, I'm going to keep change my division to be multiplication, and then I'm going to flip. Okay, so now we've got a multiplication problem. My next step is going to be factor. I'm going to factor every single thing. And because every single thing here is a trinomial, if it is factorable, we're going to factor everything into be two binomials. So m squared plus 3m plus 2 is going to factor out to be m plus 2 times m plus 1. M squared plus 5m plus 4 is going to factor out to be m plus 4. And then m plus 1. And guys, you can already see how important factoring is going to be for doing this. So if factoring is not your strong suit, please, please, please get in touch with me. Let's go over, let's figure out what you need to know to be able to factor. And factoring will come up again and again in this class. To factor out m squared plus 10m plus 24, that's going to end up being m plus 6 times m plus 4. And then bottom one, m squared plus 5m plus 6 is going to factor out to be m plus 3, m plus 2. All right, everything has been factored. Now comes the fun part. This is what every student loves to do. Let's see what we can mark out. So as long as it's common on the top and the bottom, it doesn't matter if it's diagonal or straight up and down, you can cancel it out. So let's start with the m plus 2. I got an m plus 2 here, m plus 2 there. Those two are gone. I've got an m plus 1. Ooh, I have one below it. Those two are gone. I have an m plus 4 and an m plus 4. Those two are gone. I've got an m plus 6. There is no m plus 6 on the bottom. And I've got an m plus 3 on the bottom. Nothing like that on top. So my final answer here is going to be m plus 6 over m plus 3. Remember, you are not allowed to cancel bits and pieces of binomials. So you cannot, and that goes for trinomials. That's why I couldn't just go in here and just start marking stuff out. I had to factor. So you cannot cancel out the two m's. You cannot cancel out the 6 and the 3. You were stuck with this. So my final answer is m plus 6, m plus 3. Okay, so that's multiplication and division together. I'm going to do one more problem, and I'm going to go over how to do addition and subtraction. And I'm going to put both operations in this problem. So let me clear this. Take a deep breath because we got a lot of stuff going on here. So number 38. 5x squared. No, excuse me, let's do 5x. Come on. 5x plus 2 over, there's our x squared minus 1 plus 3 over x squared plus x minus 1 over x squared minus x. Okay, now if you remember anything from fractions, when you have addition or subtraction, you have to have a common denominator. The same thing applies with rational expressions. I have to have a common denominator. Now, with numbers, it's easy to find a common denominator. You're just looking at multiples of things. When you throw in variables, it becomes harder. So for us to be able to figure out what I need to multiply together to get my common denominator, the first thing I have to do is actually come in here and factor these things out. So I need to figure out what x squared minus 1 is composed of, what x squared plus x is composed of, and x squared minus x is composed of. So I'm going to factor these. This first one, and guys, because I'm going to run out of room very quickly, I'm just going to erase these as we go. X squared minus 1 is a difference of two squares. So x squared minus 1 is going to factor out to be x plus 1 times x minus 1. All right. X squared plus x, that is not squares. I mean, the x squared is, but the x is not. So I'm going to factor out I'm going to factor out a GCF because they both have an x to give up. So I'm going to factor out an x. And when I factor out my x, that's going to leave me with x times x plus 1. Same thing over here, x squared minus x. It is a difference, but that's not a square. The first term is, the second term is not. So I'm going to erase that, and I'm going to factor out a GCF, and my GCF is going to be an x, just like the previous one. So if I factor out an x, that's going to leave me with x minus 1. Okay, so everything is completely factored. So now I need to figure out what my LCD is going to be. And I'm going to make a note of it. So my LCD. Your LCD needs to include everything that you are showing. So you need to have a version of everything. So I see x's, just plain x's. I see x plus 1, x minus 1. So I need to include all three of those. So my LCD is going to be x times x plus 1 times x minus 1. If I had a y in the bottom of one of these problems, I'd throw in a y. If I had a 2 in the bottom of one of these problems, I'd throw in a 2. So you just have to take everything that you see, and you only need one of them. So the 1x that I have is going to take care of both of the x's that I show. The 1x plus 1 is going to take care of both the x plus 1s I show, and the 1x minus 1 is going to take care of both of the others. Okay, so my LCD, this is what I want to have on the bottom of every single fraction. So by the time that I'm done, every single one of these needs to have an x plus 1, x minus 1 on the bottom. So let me change colors here. We're going to figure out what we need. So when I look at this first fraction here, I got x plus 1, x minus 1. I'm missing the x. So I'm going to multiply the top and the bottom by x. So you have to remember, it has to go to the top and the bottom. You can't give it to just one. And the reason that is because x over x is equivalent to the value of 1. So you're not changing the value, you're just changing the look of your fractions. Okay, this second fraction, what are we missing here? So I've got the x and I've got the x plus 1. I'm missing the x minus 1. So I'm going to multiply the top and the bottom by that. And then on this last fraction, I've got the x. I've got the x minus 1. So what are we missing? Well, the x plus 1. So I'm going to multiply the top and the bottom by that. So what I want you to notice here is it may be out of order, but every single thing has the x, x plus 1, x minus 1. So every single fraction that I show has that. So because I'm going to run out of room, I'm going to write it just like this. I'm going to put x, x plus 1, x minus 1, because that's on the bottom of every single fraction. And now I'm going to write what I have left over. So on top, I have x times 5x plus 2 plus 3 times x minus 1 minus 1 times x plus 1. Okay, so we've got the common denominator. Let's multiply what we have out here. So if I multiply this out, I'm going to distribute out my x, distribute out my 3. Oh, my power is going off. Maybe I didn't illusions. Okay, and I'm going to distribute out my negative 1. So if I distribute out my x, I'm going to have 5x squared. If I distribute out my x, I'm going to have plus 2x. Now let's keep going. I'm going to have plus 3x minus 3 and minus x minus 1 all over x times x plus 1